All right, this is Mr. Gilman. Today we're going to learn about the properties of operations and equalities. And so basically these are hopefully going to be properties that you've seen before. And we're just going to talk about them again, and we're going to hopefully learn them all as we practice. So let's get started. The additive identity property. Now, whenever you see identity, I want you to think that it has to keep its identity. Okay, there's an addition one, and there's also a multiplication one. So when you see the identity property, you need to be thinking it has to stay the same. So when I say algebraic definition, a plus 0 equals a. That's what it's saying. That's it. That's all it is. Okay? Basically, it's saying when you add 0 to something, it stays the same. All right? Or we could do a whole bunch of them. B plus 0 equals B, and so on. It's the same thing. Whatever you add 0 to, it stays the same. It keeps its identity. So, for example, 3 plus 0 is still equal to 3. 5 plus 0 is equal to 5. All right, now you've been using this rule since you're little kindergartners, but actually we're going to put a name with it. It's called the identity property of addition. Addition, additive, identity property. Okay, when you add 0 to something, it keeps its identity. It doesn't change. The additive inverse property is something we talked about recently when we were adding numbers together. It basically says if you have a variable, negative x, and you add its inverse, it should equal 0. All right, so x plus negative x equals 0, or negative x plus x equals 0. Either way you want to write it, or you could use a different variable if that bothers you. Oops. Means the same thing. Negative a plus a equals 0. They're opposites, or a plus negative a equals 0. Okay, it's called the additive inverse property. So 3 plus negative 3 would equal 0, or negative 2 plus 2 would equal 0. If they're opposites and you're adding them together, they equal 0. It's called the additive inverse property. Additive inverse property. It has to equal 0. All right, the next one. Multiplicative identity property. Multiplicative identity property. Basically, once again, that word identity is saying that whatever you have can't change. And hopefully everyone knows that when you multiply something by 1, it doesn't change its value. Kind of like when you're adding 0 or multiplying by 1, nothing changes. So if we had a times 1, it still equals a. Or 1 times b still equals b. Same thing. Okay? It's called the identity property. You keep your identity when you multiply by 1. 4 times 1 equals 4, or 8 times 1 equals 8, or negative 3 times 1 equals negative 3. All right. Basically, it's just a fancy name for saying when you multiply something by 1, it still is the same. It keeps its identity. Multiplicative identity. Additive, you add 0. Multiplicative, you multiply by 1. Both of those things happen. You keep the same identity. The inverse property, same kind of thing. If I had a times 1 over a, it would equal 1. Or if I had 1 over b times b, it equals 1. Okay, and we've been practicing multiplying fractions, so there's a little sidebar here. If I did do 1 over b times b over 1, we reduce, 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 reduce. 1 times 1 is 1 over 1, which is 1. So when you do the multiplication, it works out the same way. So basically, this is called multiplying reciprocals, but we're going to call it the multiplicative inverse property, and you'll have to know its specific name as well. So 1/3 times 3, that equals 1. And we've had some problems already that we've had to solve. A over 3 equals 6. Well, the reason we can multiply by 3 is because this is really saying 3 times 1/3 a equals 6. And so a would equal 18. Because this guy cancels that guy out. It's literally the multiplicative inverse property. So 1/3 times 3 equals 1, or you could say 5/2 times 2/5 also equals 1. There you go. When you multiply reciprocals or inverses, it equals 1. Commutative property of addition. That's saying if a plus b equals 3, then so does b plus a. It's also equal to 3. All right. It means it doesn't matter what order you add the numbers in, they're still going to add up to the same amount. So that works with positive and negative numbers. We call it the commutative property of addition. 3 plus 4 will equal 7, as well as 4 plus 3 equals 7. That's when you use switch order in an addition problem. Switch the order. Okay, and it also works with negative numbers as long as it's all held together by addition. Negative 3 plus negative 4 equals negative 7, or negative 4 plus negative 3 equals negative 7. Okay? Commutative property of addition. There's also a commutative property of multiplication. It says AB equals 3, then so does BA. A times B or B times A equals 3. And once again, it's just a switch order. All right. And so, for example, if I had 3 times 7 equals 21, that would be the same as 7 times 3 equals 21. Negative 2 times 4 equals negative 8, or 4 times negative 2 equals negative 8. All right. The negative still stays with the 2 on the commutative property, and that might make a difference. But as you can see, no matter which order you multiply them in, you're going to get the same result. It's called the commutative property of multiplication. You just switch the order. The associative property of addition says this. If I had a big long list of addition, like so, A plus B plus C equals 5, I could put the parentheses around the A plus B as long as it's all addition, or I could do A plus B plus C. It doesn't matter where the parentheses go because order of operations basically is invalid here. It doesn't matter because there's nothing to reduce before or after the parentheses. All right. So an example be, okay, so this one you move parentheses. That's what you're doing. Move them parentheses for the associative property of addition. So if I had 3 plus 4 plus 5, we know that equals to 12. It doesn't matter if I have the 3 plus 4 like this, or I could have it 3 plus 4 plus 5 like this. As long as it's all held together by addition, it means the same thing. It's going to be worth the same amount. You can put parentheses wherever you want. The nice thing about this property, though, is if I had like 3/4 plus 2/3 minus 1/3, like that, instead of having my parentheses there, or I could do a plus and negative 1/3, it would be much better if I looked at this part of the problem first, because they're already like terms. It's going to save me some time. So that's what the associative property really is used for, is putting terms that you like together and adding them together first. Okay? Just moves the parentheses. Multiplication is the same way. A times B times C equals whatever. It doesn't matter. 10. I could do A times B times C equals 10, or I could do A times B times C equals 10. It'll have the same outcome. All right. So what I'm going to do is I'm going to do a little example for you here. 1 times 2 times 3. That should equal 6 with the parentheses there. It should also equal 6 with the parentheses there. All right. And same idea. If I had something like 2 times 1/5 times 5, I wouldn't want to do this part first. That'd be a pain in the butt. But what I would want to do is I would want to change that to 2 times 1/5 times 5. And that just so happens to be the multiplicative inverse property. And I would know that this equals 1 because anything times its inverse is 1. But okay, that's just how you would apply it, the associative property. As long as it's all held together by multiplication, move the parentheses wherever you want. It's okay to do. Distributive property. If I had 3 times x minus 2, the distributive property, or the rainbow property, I call it, is when you multiply 3 times everything in the parentheses. 3x minus 6. Just like so. That's it. It's called the distributive property. So I could do, that's basically an example in itself. 5 times x plus 2, 5x plus 10. Okay, 5x plus 10. I don't need that parenthesis on there. Okay, there you go. Pretty straightforward. That one I think everyone knows pretty well. The addition property of equality. Okay, here's where the fun stuff begins. A plus 3 equals 4. When I subtract the same number from both sides, that is called, oops, I should change that. We'll start with a minus. If I'm adding to both sides, it is the addition property. If I'm subtracting, it's the subtraction property of equality. So it's pretty straightforward. If you're solving an equation, you're adding to both sides, it's the addition property of equality. So I'll give you another example here. B minus 3 equals 5. Or let's just make that 5. B minus 5 equals 5. If I add 5 to both sides, B equals 10. This is the step. This is called the addition property of equality. Subtraction property of equality, same thing. N plus 4 equals 2. N equals negative 2. This is the step where the property happens. And in the algebraic definition, they want more algebra involved with no numbers, but that's fine. We can leave it. Z plus 7 equals negative 2. When I subtract from both sides of my equal sign when I'm solving, then that's called the subtraction property of equality. All right, multiplication property of equality. A over 3 equals 12. That just says the inverse of division is multiplication, so I need to multiply both sides. A equals 36. Or I could do A over 5 equals 12, something like that. Same thing, multiply to get rid of that stuff. And when you're multiplying, that's called the multiplication property of equality. Division property of equality, you divide both sides. Oh, I shouldn't do that. The division step right here is the division part. Division property of equality. The symmetric property of equality just says if A equals B, then B equals A. It's like flip-flopping. It just flip-flops the equation. So if I said like, oh, 4 equals 2x, and I like the x on the left side, I could say 2x also equals 4. And then I could solve from there. It's just basically switching the parts of the equal sign on either side. And the transitive property says if A equals B and B equals C, then A also has to equal C. So if 2x equals 5 and 5 equals 3y, then 2x must equal 3y. And that's it. Transitive property of equality.